Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, it is a pleasure to present my research here at this conference entitled Integrating Religious Activity Intensity as an Anthropogenic Water Input in Urban Runoff Modeling, a behavior-informed approach in masjid environment of Indonesia and Turkey. Urban runoff modeling has traditionally focused on rainfall and land surface characteristics as the primary drivers of hydrological response. One of the most widely used approach is soil conservation service curve number method, commonly referred to CN method, due to its simplicity and practical applicability. However, most conventional runoff models still assume that runoff is governed mainly by natural process. Structured human water use is rarely incorporated explicitly into the hydrological framework itself. Right now, sociohydrology research increasingly demonstrates that hydrological systems are closely interconnected with human behavior. But most previous studies, however, still have focused on large-scale systems such as irrigation, domestic demand, domestic household, water analysis, water catchment management, and so on. In contrast, relatively little attention has been given to smaller scale but repetitive activities that generate concentrated water input on daily basis. This is why I selected masjid environment as the focus of this study. Masjid represent highly structured environment where water use occurs repeatedly through ablution, sanitation, and routine facility activities. These activities occur predictably throughout the day and involve concentrated user growth. So the reason is that masjid activities provide a uniquely structured behavioral system. Ablution patterns occur repeatedly, every day, at relatively fixed times, with relatively consistent water use behavior. So this masjid environment particularly suitable for analyzing interaction between behavioral processes and runoff generation. So, based on this background, I developed a new behavior-informed hydrological framework called Religious Activity Intensity, or RAI. RAI is the main proposed framework of this study. It was specifically developed to integrate structured human water use behavior into conventional runoff modeling. The study therefore has three main objectives. First, to develop the RAI framework itself. Second, to evaluate how behavioral water use contributes to runoff under different rainfall conditions. And third, to examine how spatial context influence system response. Religious activity intensity, or RAI, is formulated as a composite indicator derived from user density, activity frequency, and per capita water use. The framework extends the conventional curve number method by incorporating behavioral influence directly into runoff estimation. And in this proposed framework, behavior influence runoff through two interconnected mechanisms. First, it contributes directly as additional anthropogenic water input. Second, repeated water use modifies hydrological response through adjustment of the curve number, which representing increased effective surface wetness. This dual mechanism represents one of the main novelties of the proposed RAI framework. In many conventional models, human activity is treated only as an external or additive component, and in contrast, the RAI framework allows behavior to influence both the quantity and water entering the system and the runoff response itself. A question may emerge is why use the curve number method instead of more advanced hydrological model. The intention of this research was not to replace physically complex hydrological models. Rather, the objective was to demonstrate how behavioral dynamics can be integrated into a widely used and practical modeling framework. The curve number approach was selected specifically because it remains one of the most accessible method for a hydrological assessment, and it's particularly even in limited data availability. So to evaluate the analytical behavior of the proposed REI framework, I developed a simulation-based representation using 4 masjid environments with comparable spatial characteristics of approximately 2,500 square meters. But this environment were not treated as direct implementation site, but they were used as representative scenarios designed to reflect conditions that are reasonably comparable to actual masjid environment in urban and semi-urban context. I also used 3 rainfall scenarios simulated here: 10 millimeters, 30 millimeters, and 60 millimeters. Also 3 behavioral intensity levels also incorporated: low, medium, and high activity. This all together make the framework generated 36 simulation scenarios. Now when we talk about the spatial context, these 2 simulated contexts were based on conditions comparable to urban environment in Bursa, Turkey, characterized by relatively high impervious surface coverage. And the other 2 scenarios represented semi-urban institutional environments comparable to conditions in Ponorogo, Indonesia, where user density and activity concentration tend to be high. Now I will move to the main finding. The first major result is that increasing religious activity intensity consistently increases runoff across all rainfall scenarios and simulated environment. When curve number was adjusted using the behavioral component, the numerical increase in curve number appeared relatively moderate. However, because of the curve number method is inherently nonlinear, even relatively small changes in curve number will produce noticeable differences in runoff response. The most significant behavioral influence appear under low rainfall condition. Under 10 millimeters rainfall scenarios, behavioral contribution accounted for approximately 20 to 50% of total runoff in urban environment, and up to around 60% in semi-urban environment. This suggests that under low rainfall condition, the hydrological system can become behavior dominated rather than rainfall dominated. And as rainfall intensity increased, rainfall gradually become a dominant runoff driver. However, the behavioral contribution itself remained relatively constant in this simulation. Why does behavioral influence appear to decrease during heavy rainfall? The answer is that the behavioral water input itself actually does not disappear, but the rainfall generated runoff increases much more rapidly, thereby reducing the relative contribution of behavioral input within the overall runoff system. Another important finding concerns a difference between urban and semi-urban response. Urban environment exhibited stronger sensitivity to changes in surface response because of a higher imperviousness and higher baseline curve number values. Meanwhile, semi-urban environment were influenced more strongly by the magnitude of behavioral water input due to larger user population and more concentrated activity patterns. In this study, I described this tendency as response-driven system and volume-driven system. To evaluate this dynamic quantitatively, the study incorporated several indicators, including the relative contribution ratio, or RCR, which measures the relative importance of behavioral runoff contribution, and the sensitivity index, which evaluates how responsive the system is to behavioral variation. Another question that may emerge is whether the RAI framework can be applied outside massive environment. The answer is yes. Conceptually, yes, the framework can be extended to other activity-intensive environments such as campus, transport hubs, school, commercial facilities, and other public space, where structured water use contributes to runoff generation. But as I said earlier, this framework will be more effective for repeated activity that relatively fixed time with relatively consistent water use behavior, such as ablution time in masjid area. So the RAI framework demonstrates that urban hydrological systems are co-shaped by both climatic and behavioral processes. Another important contribution of this study is in its methodological simplicity. The framework extends the conventional curve number approach without requiring highly complex computation or extensive data set. So it's suitable for preliminary hydrological assessment and data limited application. Of course, the study also has several limitations. The simulations are based on representative parameter assumption rather than direct field measurement. Temporal variability and detailed drainage dynamic are also not explicitly represented within this current framework right now, because at this current stage the study remains primarily conceptual and scenario based. The objective was first to establish and evaluate the analytical capability of the proposed religious activity intensity framework itself, and hopefully future work will focus on empirical validation and calibration using field observation. Finally, to conclude, the study demonstrates that religious activity intensity consistently increases runoff across different rainfall conditions, and its influence becomes particularly significant under low rainfall scenarios, and spatial context strongly affect the nature of system response. Overall, the proposed religious activity intensity framework demonstrates that structured human activity can be integrated into hydrological modeling in a physically consistent and analytically practical manner. I hope this study can contribute to the development of more behavior-informed approach in urban hydrology. Thank you very much for your attention. I look forward for future discussion and questions. Assalamualaikum warahmatullahi wabarakatuh.